So you've got this mountain of raw, messy data, and right now it's not telling you a thing. Yet, in this explainer, we're going to tame that chaos and turn it into crystal clear insights using descriptive statistics. Let's dive right in.
We've all been there, right? Staring at a spreadsheet just packed with numbers, and you're thinking, okay, now what? Well, that exact feeling is what descriptive statistics were created to solve. They are your absolute first step to making sense of it all.
The whole idea is to take that raw mess of information and boil it down to something that actually means something. This is how we start to hear the story that's been hiding inside all that data. Okay, so what does this journey from chaos to clarity actually look like? Well, descriptive statistics really have three main jobs. First, they summarize the big picture for you, the main trends and the patterns. Second, they play detective, hunting for anything weird, like outliers and figuring out how spread out your data is. And finally, job number 3 is to build a super solid foundation for any deeper analysis you might want to do down the line. But hang on, before we can do any of that fun stuff, we got to know what we're actually working with. And it all starts with identifying your data type. This is absolutely crucial because the type of data you have literally dictates every single tool you can use from this point on. Basically, it boils down to 4 main types. You've got nominal, that's just for naming things. Then there's ordinal, which puts those names in an order. After that, we have interval for numbers with even spacing but no real starting point, no true zero. And finally, ratio data, which has that all-important true zero. All right, let's break that down a bit. So let's start with the first two, nominal and ordinal. These guys are all about categories. Think of nominal data as just putting things into different boxes, each with a label, like a laptop box, a tablet box, a smartphone box. There's no order, right? They're just different. But ordinal data, well, it also uses boxes, but these boxes have a specific ranking. Think low, moderate, high. You know that high is more than low, but the gap between them isn't necessarily equal. Okay, now for the number-based data, interval and ratio. Both of these are about measuring things, and both have equal gaps between values. So the difference between a 6 and a 7 is the exact same as between a 7 and an 8. But here's the absolute game changer, the idea of a true zero. Interval data doesn't have one. Think about a test score. Getting a 0 on a test doesn't mean you have zero knowledge in your brain, right? But ratio data does have a true zero. 0 minutes is, well, it's 0 minutes, no time at all. That's the key difference. All right, pop quiz. Let's say you're measuring daily screen time in minutes. What data type is that? Take a second and think about that true zero idea we just talked about. Did you get it? It's ratio. And why? It's simple, really. 0 minutes means exactly that. No screen time, a complete absence. It's a real absolute zero. And having that true zero is what unlocks the most powerful statistical tools you can use. Okay, so we've sorted our data into the right buckets. What's next? Now, we need to find its heart, its center of gravity. The fancy term is central tendency, but all it really means is finding that one single typical value that gives you a feel for the whole data set. And the two heavy hitters for this job are the mean and the median. You already know the mean, right? It's just the good old average. The median, on the other hand, is the number that's literally in the middle of the pack when you line everything up. Now here's the million-dollar question. When do you use which? Simple. For nice, clean, symmetrical data, the mean is great. But if your data has some crazy extreme values, we call them outliers, then the median is your best friend because it just ignores them. And this visual shows you exactly why that's so important. Just look at this. When data is skewed, those few extreme scores can literally pull the mean way over to one side. It stops being a good representation of typical. But look at the median. It's just chilling there, right in the middle, totally unbothered. It's just way more stable when things get weird. All right, finding the center is a huge step, but it's only half the story. I mean, knowing the average is one thing, but to really get the picture, you need to know how spread out everything is. Are all your data points huddled together, or are they scattered all over the map? And for that job, our number one tool is the standard deviation, or SD for short. All it is really is a single number that tells you, on average, how far each data point is from the center, from the mean. So a small SD means everything is consistent, nice and tight. A large SD, it means your data is all over the place. Let's make this super concrete. Imagine you have 2 classes, and they both have the exact same average test score. Sounds similar, right? But wait, Class A has a tiny SD of 2.0. That tells you the students are all at a very similar skill level. They're a homogeneous group. Now look at Class B. It has a huge SD of 6.5. This class is totally different. It's heterogeneous, with students from all across the skill spectrum. See? The SD tells you a critical story that the average completely misses, and it changes how you'd approach teaching each class. So, we've sorted our data, we've found its center, and we've measured its spread. Now for the really fun part, the part that's often the most powerful, visualizing it. This is where all those numbers and stats stop being abstract and become a story you can actually see. Okay, first challenge. You've got a bunch of test scores. How do you check at a glance if they follow that classic bell curve shape? You know, the one we call a normal distribution. You use a histogram. It is the perfect tool for this job. What it does is it takes your data, chops it up into little groups or bins, and then just counts how many data points fall into each one. And just like that, bam, you can instantly see the shape of your data. All right, next up. What if you want to compare the scores of, say, 3 different classes? You want to see them all side by side at the same time. For that, the box plot is your secret weapon. It is an unbelievably efficient chart. I mean, in one single picture, for every single group, you see the median, you see the spread of the main chunk of data, and it even points out the outliers for you. There is no better way to compare groups visually. Okay, last one for today. Now you're not comparing groups. Instead, you're tracking one thing over time, maybe student engagement over a few semesters. What's your go-to chart for that? That is a job for the line graph. It's so simple, but so powerful. It just connects the dots over time, and immediately you can see the trend. Is engagement going up, down, staying the same? The line graph tells you that story instantly. So there you have it. From sorting data types all the way to visualizing distributions, that is the power of descriptive statistics. It's really the essential toolkit you need to find the signal in the noise. Your data is always telling a story. The only question is, are you ready to listen?